Hello everyone, this is Ramachandran again, math tutor from Online Math for All. In this video, we are going to see the second set of 10 hard SAT math problems with step-by-step solution for each problem. Okay, let's go to the problems. In the figure shown, point C is the center of both circles. The ratio of AB to CD is 6 to 5. If the area of the largest circle is 242, what is the area of the shaded region? Okay, now let's plan how to solve this problem. To get the area of the shaded region over here, what we have to do is we have to subtract the area of the smaller circle from the area of the larger circle. The area of the larger circle is given over here, that is 242. Now, our aim is to get the area of the smaller circle. Once we get the area of the smaller circle, it has to be subtracted from the area of the larger circle, that is from 242. The resulting area is the area of the shaded region. Okay, now let me consider the information we have over here. That is the ratio of AB to CD is 6 to 5. Here we have the ratio of the lengths of the two line segments AB and CD, that is 6 to 5. Okay, now let me write the stuff over here. That is the ratio of AB to CD equals to 6 to 5. Okay, here from the terms of the ratio, if I want to get the lengths of these two line segments, what I have to do is I have to multiply the terms of the ratio here by the same non-zero number, say x. That is the length of the line segment AB equals to, we have to multiply the first term of the ratio by the non-zero number x, that is 6x. Now to get the length of the line segment CD, we have to multiply the second term of the ratio by the same non-zero number x, then we get 5x. Okay, here I got the length of this line segment CD, that is 5x. Actually, this CD represents the radius of the smaller circle, and this BC also represents the radius of the smaller circle. Then the length of this line segment BC also the same 5x. And here we got the length of this line segment AB, that is 6x. Okay, now let me write over here. And the line segment AC over here represents the radius of the larger circle. Now to get the length of the line segment AC, that is the radius of the larger circle, we have to add this 6x and 5x, then I'm getting 11x. So here I got the radius of the larger circle, that is 11x. Okay, now let me get the ratio of the radii for two circles. That is, first let me write the radius of the larger circle, then radius of the smaller circle. That is equal to, we know that the radius of the larger circle is 11x. Let me write it. To the radius of the smaller circle is 5x. Okay, here both the terms are multiples of x. So we can divide both the terms by x to simplify this ratio. Here this x will cancel out, the same here. Then I'm getting 11 to 5. Okay, here I got the ratio of the radii of two circles, that is 11 to 5. Okay, from the ratio of the radii of two circles, I'll be able to get the ratio of the areas of two circles. That is the area of the larger circle to area of the smaller circle. Now, to get the ratio of the areas of two circles, what I have to do is I have to square both the terms over here. When I square this one, I'm getting 11 square, and when I square this one, I'm getting 5 square. So this is the ratio of the areas of two circles. Okay, when I evaluate the value of this 11 square, it's 121, and when I evaluate the value of this one, I'm getting 25. Okay, here, from the terms of the ratio over here, if I want to get the areas of two circles, I have to multiply the terms by the same non-zero number, say y. That is, the area of a larger circle is equal to, we have to multiply the first term by the non-zero number y, then I'm getting 121y. Now to get the area of the smaller circle, we have to multiply this term by the same non-zero number y, then I'm getting 25y. Okay, here I got the areas of two circles, that is the area of larger circle, and here we have area of smaller circle. But already we know the area of the larger circle is given in the question, that is 242. So this 121y and this 242, both of them represent the same stuff, that is the area of the larger circle. So this 121y can be equated to this 242. Okay, let me do it. Okay, now to solve for y in this equation, I have to divide both sides of this equation by 121. When I divide both sides by 121, I am getting y equals to 2. Now to get the area of the smaller circle, we have to plug in this 2 for y over here. Okay, let me do it. Then I'm getting 25 times 2 equals to 50. Okay, here I got the area of the smaller circle. Okay, as I said earlier, to get the area of the shaded region, we have to subtract the area of the smaller circle from the area of the bigger circle. Okay, let me get the area of the shaded region. It is equal to area of the larger circle negative area of the smaller circle. We know that the area of the larger circle is 242 and area of the smaller circle is 50. Let me plug in 50 over here. Okay, when I simplify this one, I am getting 192. Okay, therefore the area of the shaded region is 192 square units. A times x negative 5 positive 4b equals to 7 times b negative 5x. The equation above has no solution where a and b are constants. The number b cannot be equal to the number m. What is the value of m? Round your answer to the nearest hundredth. Okay, here we have a linear equation. Now, let me do some simplification on the left side and the right side as well. Okay, first let me write the given equation as it is. That is a times x negative 5 positive 4b equals to 7 times b negative 5x. Okay, let me distribute this a to this x and negative 5. Then I'm getting ax negative 5a positive 4b equals to. Now let me distribute this 7 to this b and negative 5x, and I'm getting 7b negative 7 times of 5x is 35x. Okay, now let me subtract 4b from both sides of this equation. Okay, then this positive 4b, negative 4b will cancel out. I'm getting ax negative 5a on the left side. On the right side, when I combine positive 7b, negative 4b, I am getting positive 3b, then negative 35x. Okay, ax negative 5a. Now we can write the x term at first, that is negative 35x, and now we can write the constant term, that is a positive 3b. Okay, to have further understanding of this equation, now let me consider three different examples on linear equation. Okay, let me write the first example, that is 5x positive 3 equals to 4x positive 7. And the other example is 5x positive 3 equals to 5x positive 3. And the third one is 5x positive 3 equals to 5x positive 4. Now, let me consider the first linear equation over here. In this one, the coefficient of x on the left side, the coefficient of x on the right side are not equal. Then this linear equation will have only one solution. We can solve for that one solution easily. For that, we have to subtract 4x from both sides of this equation. Then I'm getting x on the left side. The 4x on the right side will cancel out. Now we can subtract 3 from both sides of this equation. This positive 3 on the left side will cancel out. I'm getting 4 on the right side. Okay, here I got that one solution, that is x equals to 4. Now let me consider the second linear equation over here. In this one, the coefficient of x on the left side, the coefficient of x on the right side are equal. Now we can subtract 5x from both sides of this equation. Then I'm getting the result 3 equals to 3. Is it a true statement or false statement? It's a true statement because 3 equals to 3. Okay, here in this equation, the variable x vanishes and I'm getting a true statement. Then this linear equation will have infinitely many solutions. Okay, now let me consider the third linear equation over here. In this one, we have the same coefficient for x on both sides of this equation. Now we can subtract 5x from both sides of this equation. Then the 5x on the left side, 5x on the right side will cancel out. I am getting the result 3 equals to 4. Is it a true statement or false statement? It is false statement because 3 is not equal to 4. Okay, in this equation, we have the same coefficient for x on both sides. But the constant term on the left side, constant term on the right side are not equal. In this case, for this equation, no solution. Okay, now let's consider the information we have over here. The equation above has no solution. That is, the given equation over here has no solution. Actually, we have simplified the given equation and we got the equation over here. Since this linear equation has no solution, we can consider the stuff what we have discussed over here. That is, the coefficient of x on the left side, the coefficient of x on the right side must be equal, and the constant term on the left side and constant term on the right side must not be equal. So that is a equals to negative 35 and the constant term negative 5a must not be equal to the constant term on the right side, that is 3b. Okay, here we have a equals to negative 35. We can plug in this negative 35 for a over here. Then I'm getting negative 5 times negative 35 is not equal to 3b. Okay, let me continue over here. When I multiply this negative 5 and negative 35, I am getting positive 175 is not equal to 3b. Okay, now let me divide both sides of this equation by 3. Then this 3 will cancel out. Then I am getting 175 over 3 is not equal to b. Or we can write the same equation as b is not equal to 175 over 3. Now let me consider the other information over here. There is the number b cannot be equal to the number m. That is, the number b cannot be equal to the number m. Okay, here we have b is not equal to 175 over 3. From the given information, we get that b is not equal to m. Therefore, the value of m is 175 over 3. Let me write it over here. Okay, here I got the value of m, but according to the instruction, we have to round our answer to the nearest hundredth. Okay, when I divide this 175 by 3, I am getting 58.3333. It keeps going. Okay, when I round this number to the nearest hundredth, I am getting 58.33. So therefore, the value of m rounded to the nearest hundredth is 58.33. A fruit orchard has 8 rows of apple trees and 4 rows of orange trees. Each row of apple trees has 15 trees that are healthy and 6 trees that are unhealthy. Each row of orange trees has 10 trees that are healthy and 2 trees that are unhealthy. The probability of selecting an apple tree given that the tree is unhealthy is equal to W. The probability of selecting an unhealthy tree given that the tree is orange tree is equal to Z. Note that W and Z are positive constants. What is the positive difference between W and Z? Round your answer to the nearest hundredth. Okay, now let me draw a tabular column and write the required stuff. Here we have the tabular column. Now let me fill this tabular column with the information what we have. Okay, the question says that there are 8 rows of apple trees. In each row, there are 15 healthy trees and 6 unhealthy trees. Okay, now to get the number of healthy apple trees, we have to multiply the number of healthy trees in each row by the number of rows. 15 times 8 is 120. There are 120 healthy apple trees. Okay, now to find the number of unhealthy apple trees, we have to multiply the number of unhealthy trees in each row by the number of rows. 6 times 8 is 48. There are 48 unhealthy apple trees. Okay, now to get the total number of apple trees, we have to add this 120 and 48. Then I'm getting 168. That is, there are 168 apple trees in all. Okay, now let's consider the other information. There are 4 rows of orange trees and each row has 10 healthy trees and 2 unhealthy trees. Now to get the number of healthy orange trees, we have to multiply the number of healthy trees in each row by the number of rows. 10 times 4 is 40. There are 40 healthy orange trees. Now to get the number of unhealthy orange trees, we have to multiply the number of unhealthy trees in each row by the number of rows. That is 2 times 4 is 8. Okay, now let's get the total number of orange trees. That is 40 positive 8. That is equal to 48. And also let me get the column total. 120 positive 40 is 160. That is, there are 160 healthy trees in all. And let me add this 48 and 8. I am getting 56. That is, there are 56 unhealthy trees in total. Now to get the total number of all trees, we have to add either these two values or these two values. In both the cases, we'll be getting the same result. When I add 160 and 56, I am getting 216. Even now, when I add this 168 and 48, I am getting the same total. So there are 216 trees in total. Okay, now let me consider this piece of information. There is a probability of selecting an apple tree given that the tree is unhealthy is equal to W. Here a probability is explained. That probability is equal to W. Okay, let me write W over here. And let's consider this piece of information. Given that the tree is unhealthy, so this gives a sample space. Now in the table, we have to consider the total number of unhealthy trees. So that is 56. Since it's a sample space, it should be written in denominator. Okay, here we have the probability for selecting an apple tree. Since we have the probability of selecting an apple tree, now we have to consider the number of apple trees in these 56 unhealthy trees. Okay, in the 56 unhealthy trees, the number of apple trees are 48. So this 48 should be written in numerator. So this is the probability given over here. That is the probability of selecting an apple tree given that the tree is unhealthy. Okay, now let's consider the other information. The probability of selecting an unhealthy tree given that the tree is an orange tree is equal to Z. Okay, let me write Z over here. And now consider this information. Given that the tree is orange tree, this is a sample space. Now from the table, we have to get the total number of orange trees. That is 48. Okay, now let me write 48 in denominator because this is a sample space. Now let's consider the probability we have over here. The probability of selecting an unhealthy tree. Okay, since we have the probability of selecting an unhealthy tree, in these 48 orange trees, we have to consider the number of unhealthy trees. Okay, in these 48 orange trees, the number of unhealthy trees are 8. So this 8 should be written in numerator. So this is the probability we have for the probability of selecting an unhealthy tree given that the tree is an orange tree. So that is equal to Z. Okay, here I got the values of W and Z. According to the information, both of them are positive constants. Our aim is to find the positive difference between W and Z. Okay, now to get the difference between W and Z, let's do subtraction between them. That is W negative Z equals to 48 over 56 negative 8 over 48. Okay, here I got the difference between W and Z, but the question says it's a positive difference. That is, this value has to be positive. So to make sure this value is positive, let me take absolute value for this one. Okay, now we have to evaluate the value of this one, and I have to round my answer to the nearest hundredth. Okay, now what we can do is we can go to Desmos graphing calculator and evaluate the value of this expression. Okay, now let's go to Desmos. Here we have Desmos graphing calculator. Now we can evaluate the value of this expression. Let me give this expression as input over here. That is absolute value for 48 divided by 56, negative 8 divided by 48. Okay, when I evaluate the value of this expression, I am getting 0.6904, and it keeps going. Our aim is to get the value rounded to the nearest hundredth. When I round this value to the nearest hundredth, I am getting 0.69. Therefore, the positive difference between W and Z is about 0.69. 3x negative 7p times 5x square positive 8x negative 4p, x cube positive 3x square negative 16x negative 48 equals to 0. In the given equation, p is a positive constant. The product of the solutions to the equation is a negative 560 over 9. What is the value of p? Okay, when I consider the stuff on the left side of the given equation, we have the product of three expressions. Okay, whenever the product of three expressions equals to 0, then the one of them has to be 0. That is, first one has to be 0, or the second one has to be 0, or third one has to be 0, because the product equals to 0. Okay, if I consider the first one is equal to 0, I am getting the equation 3x negative 7p equals to 0. And it's a linear equation, then we'll have only one solution for this equation. That is, we'll have only one value for x. Okay, now let's solve for x in this equation. Let me add 7p to both sides. When I do so, this negative 7p, positive 7p will cancel out. I am getting 3x equals to 7p. Let me divide both sides of this equation by 3. Then this 3 will cancel out. I am getting x equals to 7p over 3. Okay, when I equate this one to 0, I got a linear equation, and the solution for that equation is 7p over 3. Okay, now if I consider this one is equal to 0, I am getting a quadratic equation, that is 5x square positive 8x and negative 4p equals to 0. Since it's a quadratic equation, we'll have two solutions. Since the product of the solutions for this equation is given, what we can do is we can get the product of two solutions of this quadratic equation. For that, we can consider the quadratic equation standard form, that is ax square positive bx positive c equals to 0. When we have a quadratic equation in standard form like this one, there is a formula to get the product of the two solutions, that is equal to c over a. That is, we have to divide the constant term by the coefficient of x square. Okay, now we can use the same formula to get the product of two solutions of this quadratic equation. Okay, let me write it out here. So the product of two solutions of this quadratic equation equals to, we have to divide the constant term by the coefficient of x square. Then we get negative 4p divided by 5. Okay, here when I equate this one to 0, I got a quadratic equation, and I got the product of two solutions, that is negative 4p divided by 5. Okay, now let me erase this stuff and equate the third one to 0. Now let me equate the third expression to 0. Then I'm getting x to the third power, positive 3x square, negative 16x and negative 48 equals to 0. Okay, now I think we can solve this one by factoring. Okay, let me factor the expression we have over here by grouping. Let me consider the first two terms as one group and the next two terms as another group. Okay, when I consider the terms in the first group, the greatest common divisor for this one and this one is x square. So what we can do is that we can factor x square out. Then we get x positive 3 inside the parenthesis. And when I consider this one and this one, the greatest common divisor for these two terms is negative 16. We can factor negative 16 out, then we get x positive 3 inside the parenthesis equals to 0. Now we can consider this is one term, this is another term, and for these two terms, the greatest common divisor is x positive 3. So we can factor x positive 3 out. When x positive 3 is factored out, we get x square negative 16 over here equals to 0. Okay, x positive 3 times x square negative, we can write this 16 as 4 square equals to 0. Okay, now let me consider an algebraic identity, that is the difference of two squares, a square negative b square. Okay, whenever we have difference of two squares in this form, it can be written in the factor form, that is a positive b times a negative b. Okay, when I consider the expression over here, x square into 4 square, it's exactly in this form. So we can write this one in factor form, like a positive b times a negative b. For that, we have to take x at the place of a and 4 at the place of b. Okay, now let me write it x positive 3 times. Now we can write this one in factor form, like a positive b times a negative b. Then we get x positive 4 times x negative 4 equals to 0. Okay, here the product of three binomials equals to 0. Since the product of three binomials equals to 0, one of them has to be 0. Okay, if the first one is 0, we get x positive 3 equals to 0. If the second one is 0, I'm getting x positive 4 equals to 0. If the third one is 0, I'm getting x negative 4 equals to 0. Okay, if I solve for x in the first one, I'm getting x equals to negative 3. And if I solve for x in this one, I'm getting x equals to negative 4. And in this equation, I'm getting x equals to positive 4. Okay, now let me get the product of three solutions. There is negative 3 times negative 4 times 4. Okay, when I equate the third expression to 0, I got the product of three solutions. Okay, now let me write it over here. There is a negative 3 times negative 4 times 4. Okay, here I got the product of all the solutions to the given equation over here. According to the given information, the product of the solutions to the given equation is equal to negative 560 over 9. So it must be equal to negative 560 over 9. Okay, now we have to solve for p in this equation, and here we can do some simplification. That is 3 goes into 3 one times, and here 3 goes into 3 one times. Okay, now let's multiply this 7, negative 4 and negative 1 and negative 4 and 4. Okay, before that, first we can multiply the signs. Okay, negative times negative will be positive, positive times negative will be negative. And when I multiply the numbers 7, 4, 1, 4 and 4, I am getting 448. And here when I multiply this p and p, I am getting p square. In denominator, we have 5. That is 1 times 5 is 5 equals to negative 560 over 9. Okay, here we have negative sign and here we have negative sign. Let's multiply both sides of this equation by negative 1 to get of the negative sign on both sides. When I multiply this one by negative 1, I am getting 448 p square divided by 5. When I multiply this one by negative 1, I am getting 560 over 9. Okay, now to get of this 448 over 5, let me multiply both sides of the equation by the reciprocal of this fraction. That is 5 over 448. Let me do the same thing over here. That is 5 over 448. Okay, this one will cancel. This one will cancel out. I am getting p square equals to here this 560 and 448, both of them are even numbers, and we can simplify this one. For that, we can write a fraction with this one as numerator and this one as denominator. Then I'm getting 560 over 448. And we can write another fraction with this one as numerator and this one as denominator. Then I'm getting 5 over 9. Okay, now we can use Desmos graphing calculator to get the simplified form of this fraction. When I use Desmos, I am getting 5 over 4 as a resulting fraction for this one. Times we can write this one as it is, that is 5 over 9. Okay, p square equals to, when I multiply this two numerators of 5 and 5, I'm getting 25. And when I multiply the two denominators, I'm getting 4 times 9 is 36. Okay, our aim is to get the value of p. So we have to get of the exponent 2 over here. Now let me take square root on both sides to get of the exponent 2 over here. On the left side, the square root and square will cancel out. Usually when we take square root on both sides of an equation, for this square root, we have to consider positive or negative sign. Okay, then we get p on the left side, positive or negative. And when I take square root for the numerator 25, I am getting 5. When I take square root for the denominator 36, I am getting 6. Okay, here I get two values for p. One is p is equal to positive 5 over 6, and the other one is p is equal to negative 5 over 6. The question says p is a positive constant, so we can reject the negative value of p. Therefore, the value of p is 5 over 6. In triangles ABC and JKL, angles B and K each have a measure of 44 degrees. The length of side BC and the length of side KL are both equal to 25. Which additional piece of information is sufficient to prove that triangle ABC is congruent to triangle JKL? Okay, first let me draw the two triangles. Here I have drawn two triangles. Okay, now let me mark the vertices. Here we have A, here we have B, here we have C, and J, K, L. Okay, we have the information angles B and K each have a measure of 44 degrees. At B, let me mark 44 degrees. And here K, we have 44 degrees. And also we have the information, the length of the side BC, the length of the side KL are both equal to 25. Okay, we have BC over here, its length is 25, and KL over here, its length is 25. Okay, that's all the information we have over here. And now in the given answer choices, we have to find the one which is sufficient to prove that the triangle ABC is congruent to triangle JKL. Okay, now to verify the given answer choices, we need the triangle congruence postulates and theorems. Okay, now let me write them over here. Here I have written the postulates and theorem. The first four we have postulates, the last four we have theorems, and we use the last four to prove that two right triangles are congruent. Okay, anyways, we can start verifying the answer choices one by one. Now let me consider the information we have in answer choice A. That is the length of side AC is 13 and the length of the side JL is 13. AC is over here, its length is 13, and JL is over here, its length is 13. Okay, the length of this side of the triangle and this side of the triangle are equal, and the length of this side BC, the length of this side KL are equal, and the interior angle measure over here, interior angle measure over here are equal. That is, we have side angle. But SSA cannot be used to prove the two triangles are congruent. So the information we have in answer choice A is not sufficient to prove that two triangles ABC and JKL are congruent. Now let me consider the information we have in answer choice B. That is, the measure of angle A is 58 degrees and the measure of angle L is 58 degrees. Okay, at the vertex A in the first triangle, let me mark the interior angle 58 degrees. And in the second triangle at the vertex L, let me mark 58 degrees. Okay, here we have interior angle measure 58 degrees, here we have 58 degrees, and here we have the interior angle measure 44 degrees, here we have the same interior angle measure, and here we have the length of the side 25, here we have the length of the side 25. Now let me consider the order in which we have the stuff in the first triangle. So we have angle, and side. That is, we have S. And now let me consider the order of the stuff over here in the second triangle. That is angle, side, angle. Let me write over here, angle, side, angle. Even though AAS and ASA are triangle congruence postulates, we have two different postulates in these two triangles. Okay, if I want to prove these two triangles are congruent, I must be having the same postulate or same theorem in both the triangles. But here we have two different postulates in these two triangles. So with the information in answer choice B, I cannot prove the given two triangles ABC and JKL are congruent. Let's reject answer choice B. Okay, now let me consider answer choice C. That is, the measure of angle A is 37 degrees. Okay, now let me mark it over here, 37 degrees. And the measure of angle J is 37 degrees. Okay, here we have 37 degrees. Okay, here we have interior angle measure 37 degrees. Here we have the same interior angle measure. Here we have 44 degrees. Here we have 44 degrees. Here we have the length of the side 25 and the same length we have over here. Okay, let's consider the order in which we have the stuff in the first angle, side. Okay, let me write it over here, angle, side. Now let me consider the order of the stuff in the second triangle we have over here, angle, side. That is AAS. Here we have 37 degrees as a first angle. In the second triangle also we have the same 37 degrees as the first angle. And the second interior angle is 44 degrees. And in the second triangle also the second interior angle is 44 degrees. And the third one is a side which has a length of 25. So here also the third one is a side which has a length of 25. So, and also we have this AAS as one of the triangle congruence postulates. So using this postulate AAS, we can say these two triangles ABC and JKL are congruent. So the information we have in answer choice C is sufficient to prove the triangle ABC is congruent to triangle JKL. So the correct answer choice for this one is C. And the answer choice D is incorrect because it says no additional information is necessary. Actually, we need an additional information to prove the two triangles are congruent, and we got that additional information in answer choice C. Therefore, the correct answer choice for this question is C. If 4k negative x is a factor of x to the third power negative 72 n k cube, where n and k are constants and k is greater than 0, what is the value of n? Okay, here when I consider this stuff and this stuff, we have three alphabets k, x and n, and there is an information that n and k are constants. Then the alphabet x has to be considered as a variable. Okay, now we can consider this expression as a polynomial function p of x. That is, let p of x equals to x to the third power negative 72 times n k cube. Okay, the question says this is a factor of this one, that is a polynomial function p of x. Now I can equate this factor to 0 and solve for the variable x. Okay, let me do it. That is 4k negative x equals to 0. Now let me add x to both sides of this equation. Then negative x positive x will cancel out. I'm getting 4k equals to x. Okay, here I equated this factor to 0 and solved for x. That is x equals to 4k. Now we can consider the factor theorem. When this 4k negative x is a factor of the polynomial function p of x, then when I plug in the value of x, 4k for x over here, it must be equal to 0 according to the factor theorem. So that is a p of 4k equals to 0. Okay, now to get the stuff for p of 4k, we have to plug in this 4k for x over here. Then we have to plug in the same 4k for x over here on the right side. Then I'm getting 4k whole to the third power negative 72 times n times k to the third power equals to 0. Okay, here two values are multiplied and there is a common exponent 3. So we can take this exponent 3 separately for each value and multiply the results. Then I'm getting 4 to the third power times k to the third power negative 72 times n k cube equals to 0. Okay, the value of 4 cube is 64. That is 64 times k cube negative 72 n times k cube equals to 0. Okay, here we find k cube in common in both the terms, so we can factor k cube out. Okay, when k cube is factored, we are left with 64 in the first term and negative 72n in the second term equals to 0. Okay, here the product of two quantities equals to 0 here. So whenever the product of two quantities equals to 0, one of them has to be 0. I am pretty sure this one will not be 0 because the question says k is greater than 0. When k is greater than 0, k is not equal to 0. When k is not equal to 0, then this k cube also will not be equal to 0. That is, k cube is not equal to 0. But I want this product to be equal to 0. And when the k cube is not equal to 0, then this one must be 0. That is 64 and negative 72n must be equal to 0. Now let's solve for n in this equation. Let me add 72n to both sides of this equation. Then this negative 72n, positive 72n will cancel out. I am getting 64 on the left side. On the right side, I am getting 72n. Okay, now let me divide both sides of this equation by 72. When I do so, this 72 will cancel out. On the left side, here we can simplify this one. The greatest common divisor for the numerator and denominator is 8. That is 8 goes into 64 8 times and 8 goes into 72 or 9 times. I am getting 8 over 9 on the left side. On the right side, we have n. Therefore, the value of n is 8 over 9. The numbers a, b, c, p and w are positive constants where b is greater than c. The number a is 1150% more than the positive difference between b and c. And c is 50% of b. If a is p percent greater than c and c is w percentage of a, what is the value of p times w? Okay, now let me consider this particular information. That is, the number a is 1150% more than the positive difference between b and c. Okay, that is a equals to 1150% more than the positive difference. Then we have to add this value to 100. That is a 100 positive 1150%. Since we have the information 1150% more than, we add this value to 100% times, we have to take the positive difference between b and c. We know that b is greater than c, that is, b is bigger and c is smaller. Now to get the positive difference between b and c, we have to subtract the smaller value c from the bigger value b. That is, b negative c represents the positive difference between b and c. Okay, here I have written the statement. That is, a number a is 1150% more than the positive difference between b and c. Okay, now let me continue in the next step. When I add this one and this one, I am getting 1250% times b and c. Okay, now what we can do is we can convert this percentage to decimal. For that, we have to divide this value 1250 by 100. When I do so, I am getting 12.5. That is 12.5 times b negative c. Okay, now let me consider the other information. That is, c is 50% of b. Okay, let me write it out here. C is equal to 50% of b. Okay, here c equals to, we can write this 50% as a decimal. For that, we have to divide this 50 by 100. When I divide 50 by 100, I am getting 0.5 times b. Because when we have the word of in math, it can be considered as multiplication. Then we have 0.5 times b. Okay, now let's solve for b in this equation. For that, we have to divide both sides of the equation by 0.5. Okay, let me do it. then the 0.5, 0.5 will cancel out. C divided by 0.5 can be written as 1 divided by 0.5 times C equals to B. When I divide 1 by 0.5, I am getting 2. That is 2C equals to B. Okay, here I got the value of B in terms of C, that is B equals to 2C. Okay, now what we can do is we can plug in this 2C for B over here to simplify this equation further. Then I'm getting A equals to 12.5 times 2C. I just plugged in 2C for B over here, negative C. Then I'm getting A equals to 12.5. When I simplify this one, 2C negative C is just C. Okay, here I got the value of A in terms of C, that is A equals to 12.5 times C. Okay, now what we can do is we can consider the other information, that is A is P% greater than C. Okay, that is A equals to P% greater than means we have to add P to 100. 100 positive P percentage times this value, that is C. Okay, then we get A equals to, we can write this percentage as a fraction, that is 100 positive P divided by 100 times C. Okay, here 100 is the common denominator for 100 and positive P. Now we can split up this stuff, that is A equals to 100 divided by 100 positive P divided by 100 times C. Okay, A equals to, when I simplify this one, I am getting 1. And here we can write this P over 100 as 1 over 100 times P times C. Okay, A equals to 1 positive. When I simplify this 1 over 100, I am getting 0.01 P. Everything is multiplied by C. Okay, now we can consider the other information over here, that is C is W percentage of A. Let me write it over here. C is equal to W percentage of A. C is equal to, we can write this W percentage as a fraction, that is W over 100. And for Y of we can consider multiplication, that is times A. C is equal to, we can write this W over 100 as 1 over 100 times W times A. And the value of this 1 over 100 is 0.01 times WA. Okay, here I got the value of C. Now, what we can do is we can plug in this value for C over here in this equation. Okay, let me take this equation and let me plug in this stuff for C over here. Then I'm getting A equals to 1 positive 0.01 P times 0.01 WA. We find A on both sides of this equation. Let me divide both sides of this equation by A. This A will cancel out. Here A will cancel out. I'm getting 1 on the left side. Now we can distribute this 0.01 times W to each term over here inside the parenthesis. When I distribute this one to 1, I'm getting 0.01 W. Okay, when I distribute this one to this, first I have to multiply this 0.01, 0.01, then I'm getting 0.0001 P times W. Okay, here in this equation, our aim is to get the value of this P times W. To get the value of this P times W, still we need the value of the unknown constant W. How do you have to get the value of this W? For that, what we can do is we can plug in this stuff 0.01 times WA for C in this equation. Okay, let me plug in A equals to 12.5. And for C, we got the stuff for 0.01 times WA. Let me plug in over here. That is 0.01 times WA. Okay, now let me continue over here. A equals to, when I multiply this 12.5 and 0.01, I am getting 0.125 times WA. My aim is to get the value of W. So let me divide both sides of this equation by 0.125 times A. Okay, now let me do the same thing on the left side, 0.125 times A. Okay, here the 0.125, 0.125 will cancel out, and here A will cancel out. Here A goes into A 1 times, and here A goes into A 1 times. I am getting 1 over 0.125 on the left side. On the right side, we have W. Okay, when I divide this 1 by 0.125, I am getting 8. On the right side, we have W. Okay, here I got the value of W, that is W equals to 8. Okay, now what I can do is I can plug in this value 8 for W over here. Then I'm getting 1 equals to 0.01 times 8 positive 0.0001 P times W. Okay, 1 equals to, when I multiply this one and this one, I am getting 0.08 positive 0.001 PW. Okay, now we have to solve for PW in this equation. Now let me erase this stuff and continue the problem. Now let me take this equation as it is, that is 1 equals to 0.08 positive 0.0001 PW. As I said earlier, we have to solve for p times w. For that, we have to isolate this one. Okay, first let me get rid of the 0.08. For that, we have to subtract 0.08 from both sides of the equation. Okay, let me do it. Then the positive value, negative value will cancel out. When I simplify this one, 1 negative 0.08, I'm getting 0.92. On the right side, we have 0.0001 PW. Okay, since our aim is to solve for PW, we have to get rid of this value. Okay, now let me divide both sides by 0.0001. Okay, let me do the same thing on the left side as well. Okay, here this one will cancel out. When I divide 0.92 by 0.0001, I'm getting 9200. On the right side, we have P times W. Okay, here I got the value of P times W. Its value is 9200. 10b positive 6a times x square, positive 9a square, negative 25b square times x, negative 12 times ab equals to 0. The equation above has two real solutions where a and b are constants. The sum of the solutions to the given equation is k times 21a negative 35b, where k is a constant. What is the value of k? Okay, the question says a, b and k are constants. Then we have to consider the x as a variable. Then it is a quadratic equation in standard form. That is ax square positive bx positive c equals to 0. We consider this one as a standard form of a quadratic equation. Usually when we solve a quadratic equation, we will be getting two solutions. That is two values for the variable x, and there is a formula to get sum of the two solutions, that is negative b over a. We take negative sign, and here this b is the coefficient of x and it is divided by a. A is the coefficient of x square. Okay, now let's consider the information we have over here. That is the sum of the solutions to the given equation is k times 21a negative 35b. That is sum of the two solutions equals to k times 21a negative 35b. Okay, for this sum, we can find the stuff using the formula we have over here. That is, first we have to write the negative sign, then we have to take the coefficient of x. In our quadratic equation, the coefficient of x is 9a square negative 25b square, and a is the coefficient of x square. The coefficient of x square over here is 10b positive 6a equals to k times 21a negative 35b. Okay, here we can factor this expression. Okay, now let me do that separately. Let me take this expression 9a square negative 25b square, and we can write this 9 as 3 square, and also here we have a square negative. We can write this 25 as 5 square, and we can take this b square as it is. We can write this 3 square times a square as 3a the whole square negative, and we can write this one as 5b the whole square. Now let me consider an algebraic identity, that is the difference of two squares, a square negative b square. We can write the difference of two squares over here in factor form, that is a positive b times a negative b. Okay, when I consider this expression, it's exactly in this form, a square negative b square. At the place of a, we have 3a. At the place of b, we have 5b. So to get the factor form for this one, we have to use the product of two binomials over here. At the place of a, we have to write this 3a. That is 3a positive. For b, we have to write 5b. So the same we have to do for this one as well. That is 3a negative 5b. Okay, here I got the factor form of this expression. Now let me plug in this factor form for 9a square negative 25b square over here. Then I'm getting negative 3a positive 5b times 3a negative 5b. Okay, divided by, when I consider the terms of the expression in denominator, both the terms have the greatest common divisor 2. So we can factor 2 out. When 2 is factored out, to get the stuff inside the parentheses, we have to divide the terms by the one I factor out. When I divide this 10b by this 2, I am getting 5b positive. When I divide this 6a by 2, I am getting 3a equals to k times, here when I consider the stuff inside the parentheses of both the terms 21a and 35b have the greatest common divisor 7, so we can factor 7 out. When 7 is factored out, to get the stuff inside the parentheses, let's divide both the terms by the one I factor, that is 7. When I divide this 21a by 7, I am getting 3a negative. When I divide this 35b by 7, I am getting 5b. Okay, here we find 3a positive 5b, here we find 5b positive 3a. Actually 5b positive 3a and 3a positive 5b, both of them are same. So we can cancel this one and this one. Then the resulting equation is a negative of 3a negative 5b divided by 2 equals to k times 7 can be written as 7k times 3a negative 5b. Okay, now let me erase this stuff and continue the problem. Let me take this equation as it is. That is negative of 3a negative 5b over 2 equals to 7k times 3a negative 5b. Okay, according to the question, we have to find the value of k. To get the value of k, we have to get rid of this 7 and also this 3a negative 5b. For that, let me multiply both sides of this equation by 1 over 7 times 3a negative 5b. Let me do the same thing on the left side as well. That is times 1 over 7 times 3a negative 5b. Okay, here this 7 will cancel out. This 3a negative 5b, 3a negative 5b will cancel out. Here 3a negative 5b, 3a negative 5b will cancel. That is here 1 times, here 1 times. Okay, here we have negative 1 in numerator. 1 times negative 1 is negative 1. And here we have 7 times 1 is 7. 7 times 2 is 14. On the right side, we just have k. That is k times 1. Okay, here I got the value of k. It is negative 1 over 14. T of x equals to 3/4 times 26 over 7 times x negative 800, positive 15.50. Ramachandran invented a new temperature scale. Is called the online math for all scale. The function t gives the temperature in degree tot that corresponds to a temperature of x degrees Celsius. If a temperature increased by 3.3 degree tot, by how much did the temperature increase in degrees Celsius? Round your answer to the nearest hundredth. Okay, here in the given equation, this T of x represents a temperature in degree tot and x over here represents a temperature in degrees Celsius. Now, we can use Desmos graphing calculator to solve this problem easily. For that, instead of T of x, we can consider y. This y represents the temperature in degree tot because we consider this y instead of T of x. Okay, now I'm going to increase this value y by 3.3 according to the information we have over here. When the value of y is increased by 3.3, what is the corresponding increase in x? That is the temperature in degrees Celsius. Okay, now what I plan is let me plug in y equals to 0 and get the corresponding value of x. Now, let me increase the value of y, that is from 0 to 3.3. Okay, here I increase the value of y by 3.3. That is, I increase the temperature by 3.3 degree tot. Okay, when I take 3.3 as value for y, what is the corresponding value of x? Now, we are getting two values for x. One value of x is for y equals to 0 and other value of x is y equals to 3.3. Now we have to get the corresponding increase in the value of x, that is the increase of temperature in degrees Celsius. Okay, now in Desmos graphing calculator, we can give this equation as input and then we have to plug in y equals to 0 and get the value of x. And also we have to plug in y equals to 3.3 and we have to get the corresponding value of x. Then we have to get the difference of these two values to know how much the value of x is increased. That is how much the temperature in degrees Celsius is getting increased. Okay, now let's go to Desmos graphing calculator. Here we have Desmos graphing calculator and now let me give the equation as input. That is y equals to 3 over 4 times 26 over 7 times x negative 800 positive 15.50. Okay, here I got the graph of the equation. It's a straight line. Okay, now let me take the first value of y, that is y equals to 0. Okay, then we get an horizontal line over here and we got the value of x when y equals to 0. Okay, now let me note down this value. Okay, now let me give the second value of y, that is y equals to 3.3. Okay, when I give y equals to 3.3, I get another horizontal line in green color. Okay, now let me get the point of intersection over here. When y equals to 3.3, I'm getting x equals to 211.00513. Okay, 1 second. Here a point of intersection and here a point of intersection. Okay, now when I increase the value of y by 3.3, that is from 0 to 3.3. So here I got the corresponding values of x over here and here. Now I have to find how much x is getting increased. That is how much the temperature in degrees Celsius is getting increased. For that, we have to find the difference between the two x values over here. That is, we have to subtract the smaller value of x from the bigger value of x. Okay, now let me do the calculation over here. First, let me take the bigger value of x, that is 211.00513. Negative, the smaller value of x is 209.82051. Okay, here I got the difference. That is how much the value of x is getting increased. that is 1.18462. According to the instruction, we have to round this value to the nearest hundredth. When I round this value to the nearest hundredth, I am getting 1.18. That is, when the temperature in degree tot is increased by 3.3, then the temperature in degrees Celsius is increased by about 1.18. A circle has center A and points B and C lie on the circle. Line segments BD and CD are tangent to the circle at points B and C respectively. The measure of angle BDC is 120 degrees. The length of line segment CD is 12 inches. What is the area of the region that is both inside the quadrilateral ABCD and outside the circle in square inches? Round your answer to the nearest hundredth of a square inch. Okay, first let me draw a figure from the given information so that I'll have some clarity on what has to be done. Okay, now let me draw a figure. Here I've drawn a figure for the given information, and this figure is not drawn to scale. Some measures on the figure over here will be inappropriate. Okay, now let me mark the given information on the figure. The center of the circle is A. Okay, now let me mark A over here, and we have the points B and C on the circle. Okay, now let me take the point B over here and C over here, and the line segments BD and CD are tangent to the circle at points B and C. Okay, here when I consider the two line segments BD and CD, I find D in common. That means these two line segments drawn as tangents to the circle from the same external point, and that is D. So we can consider point D over here. And the measure of angle BDC is 120 degrees. So here we have the measure of angle BDC. This is 120 degrees. Okay, the length of the line segment CD is 12 inches. Here we have the length of the line segment, and that is a tangent 12 inches. Okay, whenever we draw two tangents to a circle from the same external point, they must be equal in length. So then the length of this line segment BD also must be 12, because both CD and BD are tangent to the circle from the same external point D. Okay, now what I'm going to do is I'm going to consider the question, that is what is the area of the region that is both inside the quadrilateral ABCD and outside the circle. So that is, we have to find the area of the region that lies inside the quadrilateral but outside the circle. So this is the area we have to find. So this area lies inside the quadrilateral ABCD over here, and also it's outside the circle. So how do you have to get the area over here that has been shaded? For that, we have to get the area of the quadrilateral ABCD over here. So once we get the area of this quadrilateral, from this area, we have to subtract the area of the sector over here. When I subtract the area of the sector from the area of the quadrilateral, I'll be getting the area of the region which lies inside the quadrilateral and outside the circle. Okay, now let's plan how to get the area of the quadrilateral. For that, let me connect the center of the circle A and the external point D. Whenever two tangents are drawn to a circle from the same external point, the two tangents along with the two radii of the circle will form a quadrilateral. And when we connect the center of the circle and the external point, that is in this case the line segment AD, it will divide the quadrilateral into two congruent triangles. The area of this triangle over here, the area of this triangle over here will be equal. Now our aim is to get the area of one of these two triangles. Once I get the area of one of the two triangles, it can be multiplied by 2 to get the area of the quadrilateral ABCD over here. And also at the point of tangency, the angle between the radius and tangent is always a right angle. That is, here we have right angle and here we have a right angle. And we know that the measure of angle BDC over here is 120 degrees. It's given in the question itself. And this angle will be bisected by this line segment AD. So this 120 degree angle measure will be divided into two equal parts. There is a measure of angle over here is 60 degrees and the measure of angle over here is 60 degrees. Then what is the measure of angle over here? Then it has to be 30 degrees, because here we have right angle, that is 90 degrees, here we have 60 degrees, then it must be 30 degrees, so that the three interior angles of this triangle will add up to 180 degrees, and the same stuff we have over here, that is we have 30 degree angle measure over here, 30 positive 60, 90, 90 positive 90, 180. Now let me consider the right triangle ACD over here. Actually, it is a 30, 60, 90 special right triangle. In 30, 60, 90 special right triangle, the side which is opposite to the smallest interior angle 30 degrees is the shortest leg. Okay, in this triangle, CD is the shortest leg, and usually we assume X as the length of the shortest leg of 30, 60, 90 special right triangle. Then the next longer leg is the side of the triangle which is opposite to the interior angle 60 degrees. Now to get the length of the next longer leg, which is opposite to 60 degrees, we have to multiply the length of the shortest leg x by square root of 3. Then the length of this leg AC is x times square root of 3. We know that AD is the hypotenuse of this triangle because it is opposite to the right angle, and also this is the longest leg of this triangle. To get the length of this hypotenuse AD, we have to multiply the length of the shortest leg by 2, then we get 2x. Always we have to remember this stuff in 30, 60, 90 special right triangle. Already we have the length of the shortest leg CD, that is 12. Okay, instead of x, we can consider this value 12. Okay, here we can plug in 12 for x over here and here. When I do so, I am getting 12 times square root of 3 as the length of this leg AC. And already we got 2x. When I plug in x equals to 12, 2 times 12 is 24. The length of the hypotenuse is 24. Anyways, it's not required for this problem. Okay, now in this right triangle ACD, the length of the two legs AC and CD are 12 times square root of 3 and 12 respectively. Okay, in a right triangle, apart from the hypotenuse, in the remaining two legs, we can consider one of the legs as a base and the other leg as a height. Okay, in this right triangle ACD, we can consider this leg CD as a base and this leg AC as a height. Okay, now we can get the area of this triangle ACD. Okay, now let me write the stuff over here. That is area of triangle ACD equals to, we have the formula to get area of triangle, that is a base times height divided by 2. Okay, here the base of the triangle is 12 and the height of the triangle is 12 times square root of 3. Let me plug in, divided by 2. Here 2 goes into 2 1 times and 2 goes into 12 6 times. I am getting 6 times 12 square root of 3 is 72 square root of 3. Okay, here I got the area of one of these two triangles. As I said earlier, to get the area of the quadrilateral ABCD, we have to multiply the area of one of the two triangles by 2. Okay, now let me get the area of the quadrilateral. Area of quadrilateral ABCD equals to 2 times the area of one of the two triangles, that is 72 times square root of 3. Then we get 144 times square root of 3. Okay, here I got the area of this quadrilateral ABCD. Now my aim is to get the area of the sector over here, and there is a formula to get area of a sector. Okay, let me write the stuff over here. Area of sector equals to, actually the sector is a part of the circle, theta divided by 360 degrees times the area of the square, that is pi r square. Okay, here this theta is the central angle of the sector. Okay, this is the central angle of the sector. The measure of the central angle of the sector is 30 positive 30, that is 60 degrees. Okay, now let me plug in 60 degrees for theta over here, divided by 360 degrees times pi. This R represents the radius of the circle. Actually, the line segment AC over here represents the radius of the circle. Its length is 12 times square root of 3. That is, the radius of the circle is 12 times square root of 3. Okay, now let me plug in 12 times square root of 3, the whole square. Okay, here 60 goes into 61 times and 60 goes into 366 times. I am getting 1 over 6 times pi times. Okay, here two values are multiplied and there is a common exponent 2. Now we can take this exponent 2 for these two values separately and multiply the results. Then I'm getting 12 square times square root of 3, the whole square. Okay, 1 over 6 times pi times, the value of 12 square is 144. And here this square and square root will cancel out. I am getting 3. Okay, 6 goes into 6 1 times and 6 goes into 24 times in 144. Okay, here 1 times 5 is 5. Pi times 24 is 24 pi. 24 pi times is 72 pi. Here we got the area of this sector, that is 72 pi. As we planned earlier, to get the area of the region which lies inside the quadrilateral and outside the circle, we have to subtract the area of this sector, 72 pi, from the area of the quadrilateral ABCD, that is 144 square root of 3. Okay, now let me write the stuff over here. That is, the required area equals to the area of the quadrilateral 144 times square root of 3, negative area of the sector, that is 72 pi. Okay, we'll be getting this area in square inches because we have one of the measurements, that is the length of line segment CD is 12 inches. So all the areas that we get over here, here and here will be in square inches. Okay, now we have to evaluate the value of this expression and round our answer to the nearest hundredth of a square inch. Okay, now we can go to Desmos graphing calculator to evaluate the value of this expression. Here we have Desmos graphing calculator. Okay, now let me give the expression as input. That is 144 times square root of 3 negative 72 pi. Okay, here I got the value of the expression, that is 23.2206. It keeps going. According to the instruction, we have to round this value to the nearest hundredth, then I'm getting 23.22. Therefore, the required area is 23.22 square inches. Hope you have understood all 10 hard SAT math problems I explained so far. Keep watching our YouTube channel for more digital SAT math content, and also you can visit the URL given over here to have more digital SAT math problems. Thank you.